Welcome to another Mr. Paul video. Today we're discussing 12.1, the Pythagorean Theorem. The Pythagorean Theorem. What's the Pythagorean Theorem? Well, a long time ago, there was a guy named Pythagoras. It was about 500 BC. And back then they had really strange names. His name was Pythagoras. And he came up with this cool math rule, which in math we call rules theorems. So Pythagorean Theorem, it sounds complicated, but what it basically is a guy named Pythagoras. It's named after him. So it's an old guy math rule. And what it has to do is with right triangles. As a matter of fact, it's only used to solve for missing sides of a right triangle, meaning you can only find a missing side and only of a right triangle. Okay? So what exactly is a right triangle? Well, suppose this is a triangle. A right triangle is a triangle with a right angle in it, meaning you have a box down here in the bottom corner in one of the corners, and it tells you that one of the angles is 90 degrees. So this is an example of a right triangle, and on each side of the triangle, it has a specific name, and we will be focusing on trying to convert our language from side and long side to the words that I'm about to announce now. So when dealing with triangles, we use lowercase letters to introduce sides. If you're trying to say the sides of a triangle, you're using lowercase letters. If you're talking about the angles, you're talking about uppercase letters. Since we're only dealing with sides, we're going to deal with only lowercase letters, namely A's, B's, and C's. On a right triangle, however, these A's and B's and C's have names, and they belong in a specific place. So, for example, the longest side is going to be called the hypotenuse. The hypotenuse. Okay, the hypotenuse. It's a strange name, but it basically means it's the longest side of a right triangle. And you can always locate it. It's always right across from the right angle. It's always going to be right across from it. The other two sides are called legs. In math, the two shorter sides are called legs. The easiest way that I like to remember it is instead of saying hypotenuse, this reminds me of a hippopotamus. Hippopotamuses are huge. They're the biggest. And hippopotamuses have legs. It's corny, I know. Bear with me. But we're going to try and switch to using the language hypotenuse and leg and leg. That's kind of the breakdown of what it means to be the triangle. However, we said that we were going to find some missing sides. So let's find a triangle that has a missing side. Suppose, this is our first example, we have a triangle that looks like this. We are given that this side is 3, this side is 4, and this side is missing. Now, I do want to point out that this is only used for solving sides. Well, I have a missing side, and only of right triangles. And to make sure that you guys understand that this is a right triangle, I have to put this box in the bottom corner that I'm claiming is 90 degrees. Now, this is a 90-degree triangle a right triangle, because that's a 90 degree in it, and it's missing a side. So now I get to use the Pythagorean Theorem. Well, what is the Pythagorean Theorem? It simply states that a squared plus b squared equals c squared, which is why we introduced the sides of a triangle earlier. A's and B's and C's are referring to the sides of the triangle. So if we can understand that C is meant to be the longest side and the other two are legs, we can identify in this triangle which two have to be legs and which one has to be the longest side. But once again, hippopotamuses are huge. They're the biggest side. It's the one that's opposite the 90-degree angle. So this question mark, this number that I don't know, I'm going to label this C, because I know that this one is the longest side of all the sides in the triangle. As far as A and B, they're both legs. They are interchangeable. A and B could be located A and B or B and A, and it doesn't matter. The legs do not matter when labeling. Okay? So for this particular example, I'll use this as A and I'll use this as B. Being able to understand which side of the triangles are A and B and which side is C. C is the most important one. It's given a special name for a reason. Okay, I have to identify that first. After that, the legs don't matter. Well, if I'm going to use Mr. Pythagorasis formula, I have a squared plus b squared equals c squared. Okay, but I do know what a is. A is 3. So I can think of this as 3 squared. Plus, I know what b is. I can think of b as 4. So b squared becomes 4 squared. And that's equal to c squared. And I don't know what c is, so I'm going to leave it as c squared. I'm going to just leave c alone. I'm trying to solve for c. Here comes that algebra again. 3 squared. Well, remember exponents. 3 squared is just 3 times 3. 3 times 3 is 9. And I'm adding that to 4 squared. Now, 4 squared is 4 times 4. So 4 times 4 is 16. And that's equal to c squared. Let's see. 16 plus 9. Well, I know what that is. That's 25. And that's equal to c squared. Now, we've talked about this in previous videos, but I want to refresh our memory that math always comes in pairs. To teach you how to count up, then they teach you how to count down. It's the opposite of each other. When they teach you how to add, then they teach you how to subtract. They teach you to multiply. They teach you to divide right after that. When dealing with exponents, the opposite of an exponent is called a root. To get rid of a square, which is what this is, a square, remember, is any number to the power of 2. To get rid of a square, I need to do what's called a square root. It's denoted by the symbol here. Okay, the square root of a square is just the number c, just the number that's being squared. But whatever I do to one side, I have to do to the other so that I can say that both sides are equal. The square root of 25, I'm thinking to myself, what number times itself is equal to 25? Or I can grab a calculator. Either way you'd like to do your square roots, I suggest a calculator, not for this example, but for future examples because they get a lot more complicated. But the square root of 25 is 5. C is equal to 5. Means this side length, this missing side length, is equal to 5. Remember this step. This is where we're most likely going to get stuck in a lot of our examples. C squared is equal to 25. Not the value of c. C times itself is equal to 25. And I only want one c. Okay? Let's take a look at another example. Suppose we have another example, and this time maybe my triangle is facing some way like this, and I'm going to tell you it has a right angle in it. I'm then going to tell you that this side is equal to 15, this side is equal to 8, this side I do not know. Now again, this can only be used to solve the missing side. I have a missing side. And of a right triangle, it is a right triangle because it has a right angle in it. I'm now able to use my old guy math rule, my Pythagorean theorem. A squared plus b squared equals c squared. To be able to use this, remember, I have to understand that c is my longest side and a and b are the legs. So my first step is to identify which of these sides is the longest. It's hard to tell, but I can always guess. I can always tell because it's opposite my 90-degree angle. So this is going to be C. It is the longest side, which means that this side could be B and this side could be A. And it doesn't matter which one's which because the legs are irrelevant, which one's A and B. I just have to identify them as legs. Well, let's see. A squared is like saying A is 15. So 15 squared. And that's plus B squared. Well, B is 8. So this is 8 squared. And that's equal to the unknown number. So I'm going to leave that as C squared. 15 squared is 15 times 15. That's 225. 225. And that's plus 8 squared. Now 8 squared is 64. 8 times 8 is 64. And that is equal to c squared. Now 225 plus 64, okay? 225 plus 64 is 289. And that's equal to c squared. Now again, we do not want c squared. Remember, we're trying to find out what the value of c is, not c squared. So c squared is equal to 289. I want to undo a square. I want the opposite operation of a square, which is called a square root. So I'm going to take the square root of both sides. If I do, c squared, taking the square root of that, just becomes c. It gets rid of the square. The square root of 289 is 17. The square root of 289 is 17. Okay, now you can punch that into your calculator. Okay, use the square root symbol. The square root of 289 is 17. That means that this missing side is equal to 17. Okay, we've done two examples where we have the missing hypotenuse. Does this work for any side, or does it only work for the missing hypotenuse? Let's take a look. I'm going to erase this. Suppose, here's another example. Suppose we have a triangle, but this time we know what the longest side is. We know what the longest side is. Suppose the longest side is equal to 25. I'm going to make this a right triangle, and suppose I know what another side is in 15. And I want to know what the question mark is. It's used for solving a side, which I'm missing a side, and a right triangle only in its right triangle. So how can I use the Pythagorean theorem to help me solve for this other side? It's the same exact process, and we'll see what's different. Once again, my hypotenuse is the longest side, and it's located across from the 90-degree angle. So this can be identified as my longest side. So this number has to be smaller than that because it's not across from that. So I know I'm thinking ahead, okay, it has to be smaller than 25. So keeping that in the back of my mind. But this has to be C. It doesn't matter which one's A or B. So let's just say that this is A and this unknown number is B. If I'm going to use the Pythagorean theorem, I know that A squared plus B squared equals C squared. But now I'm going to plug in the information that I do know. Well, I know A is 15, so we have 15 squared, plus I don't know B, so let's just say this is B squared, and that's equal to C, but C is 225, is 25, and that's squared. Okay, all I'm doing is plugging in C and A because I know C and A. Okay, well, now I'm stuck than I was before because this B isn't by itself. But luckily, we just got through algebra and we do know how to get an unknown thing by itself, similar to the way that we solved for X. I'm going to solve for these numbers for now, just because it clears things up for me and I like to keep it clear. 15 times 15 is 225. And that's plus B squared. And then 25 times 25. Okay, 25 times 25 is 625. Okay, I'm trying to get B squared by itself. And just like I can imagine that this was like an X, if I wanted to get this by itself, I don't want this here. I can get rid of it by subtracting 225 from this side of the equation. And whatever I do to one side, I want to do to the other to make sure that both sides remain equal. This cancels. What's left is B squared. 625 minus 225 is 400. This looks familiar. This looks like what I'm used to. b squared is equal to 400. I want to take the square root of b. The square root of b squared. Remember, it undoes the square. The square root of 400. b is equal to 20. b is equal to 20. 20 times 20 is 400. So this missing b is 20. And it makes sense. Remember, we said that this number we knew had to be smaller than the largest side. And this kind of confirms that we didn't make a mistake. If it was larger than 25, I know I made a mistake somewhere. Okay? There is one other way, which I do want to point out, of solving, instead of this equation, we can rewrite the original equation to make our life a little bit easier. Okay? We could rewrite this original equation to do the exact same thing as well if we so choose. So if we know that we're going to be missing one of the a's or the b's, we could simply subtract it in the beginning and leave everything on one side. So for example, if I know that I don't have the b, I could subtract the a squared here and subtract the a squared here, which would mean that b squared equals c squared minus a squared. You can see how we can modify this equation in the beginning, and then all we have to do is plug in our c and our a, our c and our a. I will leave that up to you, whether you would like to rewrite your formula first or whether you would like to do the math. I personally like to do the math because I've practiced it. Okay? So for this next example, I'm going to not instead use this. I don't want to use this, even though you can. It's an option to you if you like just using formulas. But instead, I'm going to do the algebra that I'm used to and I'm accustomed to. So let's get another example where we have a hypotenuse, but we're missing one of the sides. Suppose we have a triangle that looks something like this. And I'm going to make it 90 degrees. I'm going to make this 60. And then I'm going to make this 48. And I'm going to make this a question mark. We have a missing side to a right triangle. This is a side. This is a right triangle. Once again, I have my old faithful Pythagorean Theorem. A squared plus b squared equals c squared. Okay. Well, let's see. To be able to use this, I need to identify what's A, what's B, what's C. The longest side opposite the 90-degree angle has to be C. These other two, they don't matter which one's which. This time, maybe I'll say my unknown is A this time. Last time I did B. This time it's A. I'll leave this one B. And again, it doesn't matter which one's A and which one's B because they're both legs. So let's plug in the stuff that we know. So A is unknown. We still have A squared plus B squared. So this is 48 squared. And that's equal to C squared. But C is 60. So this is 60 squared. Okay, so let's do some math here. A squared plus, now 48 squared is equal to 2304. It's a big number, but that's okay. Now 60 squared is 3600, right? 6 times 6 is 36 times 2 zeros. Okay, again, I have an unknown plus some number, and that's equal to 3600. And I want this by itself. I can use this one extra step to be able to solve for a squared, right? To be able to use my square root, I just need one extra step, and I'm going to use my old faithful algebra tactics. I will subtract 2304 from the left-hand side, and I'll subtract 2304 from the right-hand side to maintain that both sides are still equal. What's left on this side is a squared because this number cancels out. And then 3600 minus 2304 is 6921. 1296. Okay, 1296. Well, let's take the square root of both sides. Square root, A is equal to 36. A is equal to 36. 36 times 36 is 1296. Okay, and it makes sense that this would be 36. It is smaller than the hypotenuse. So it does give us comfort that we at least made some good choices. Okay, so this formula can be used to solve the missing hypotenuse or either of the two legs. If it's the legs, you have one extra step. If it's the hypotenuse, you're just plugging in information and solving for what it is. That's all for today's video. I genuinely appreciate you guys. Peace.